Imagine you're running a growing tech startup. You've been building your revolutionary new application on Amazon Web Services, and you finally need to migrate a massive data set,
Right.
say like 100 terabytes out of their ecosystem to a different partner. Now, getting that data into AWS was frictionless. I mean, it was practically free.
Oh, yeah, they make the onboarding incredibly easy.
Exactly. But hitting the download button to leave, you suddenly get hit with a bill for over $100,000
Ouch.
just in transfer fees. Welcome to today's deep dive.
It's brutal.
Our mission today is to explore this massive collision course happening right now in the tech world. On one side, we have an artificial intelligence boom that is demanding, well, just unimaginable amounts of computing power.
Right, which is propping up a centralized cloud oligopoly that is essentially holding our data hostage.
Yeah, and on the other side, we have a decentralized, crowdsourced solution rising up to meet it, potentially disrupting everything we know about how the internet is physically built.
It really is a fascinating pivot. I mean, we're looking at a structural breaking point for the cloud, both financially and physically. And the solution to a trillion-dollar hardware shortage might literally be sitting in your driveway or, your home office right now.
Today, we're pulling from a really diverse stack of sources. We've got a World Economic Forum environmental report, some eye-opening enterprise cloud pricing guides, and cutting-edge sector analysis from early 2026 on a movement called DePIN.
Yeah, DePIN is huge right now.
But before we get into what DePIN actually is, we need to understand why the current system is cracking under pressure. The WEF report lays out a scenario that's just hard to ignore.
Absolutely.
We already know data centers consume a lot of power. They currently account for about 1% of all energy-related greenhouse gas emissions globally.
Which is already a lot.
Right. But with the AI boom, that power demand is set to see a 160% increase by 2026.
Which is an infrastructure nightmare, frankly. I mean, a 160% jump isn't just a minor upgrade.
No, not at all.
It is asking an electrical grid built over a century to suddenly more than double its capacity for a single sector, almost overnight.
Wow.
We're talking about rolling blackouts if the physical footprint of these mega data centers isn't managed. And the big IT providers, well, they know this, of course.
Right. The WEF case study highlights how companies like NTT Data are scrambling to mitigate the damage. Like in India, they've started deploying direct-to-chip liquid cooling.
Yeah, because traditional air conditioning just can't keep up with the heat AI processors generate.
Water is vastly more efficient at capturing and moving heat than air, right?
Correct. It's essentially plumbing running directly over the processors to drastically lower their power usage effectiveness. And they're actually taking it a step further in Germany.
Oh, right, the Berlin facility.
Exactly. At their Berlin 2 data center, rather than just venting that massive amount of waste heat into the atmosphere, they're capturing it and routing it to provide carbon-free heating for over 1,000 buildings in the Marienpark district.
Which is a brilliant engineering feat. I mean, heating a neighborhood with server exhaust is incredible.
It really is.
But it still feels like we are putting a highly advanced Band-Aid on a fundamental flaw, because the physical constraint is only half the story.
Yeah.
The financial constraint is arguably worse. The cloud market today is, for all intents and purposes, an oligopoly.
The 2025 software pricing data makes that incredibly clear. AWS commands 31% of the global cloud market.
Wow.
Azure sits at 25%, and Google Cloud has 11%. When three companies control that much of the core infrastructure of the digital world, they wield immense pricing leverage over anyone trying to build on the internet.
Okay, let's unpack this. Because that $100,000 transfer fee I mentioned at the top of the show.
Yeah, the dirty secret.
Right, the dirty secret of cloud computing. They're called egress fees. Centralized providers charge something like 9 cents per gigabyte just to move your own data out of their systems.
It is effectively a hostage situation.
It's like moving into a luxurious walled city where the gates are wide open and the toll roads in are completely free. But the moment you try to pack up your car and leave, the guards bankrupt you.
That's a great way to put it. And if you look at the mechanism of why they do this, it's all about capital expenditure.
Okay.
Building a mega data center requires billions of dollars up front for land, servers, specialized cooling, power contracts. They need to guarantee a return on that massive investment, so they create a moat.
Right, the egress fees lock you in.
Exactly. But that centralization also creates severe vulnerabilities. I mean, we've seen it happen. One single AWS availability zone goes offline due to a power failure, And half the internet banking apps, streaming services, smart home devices just goes completely dark.
So we have a system that is physically damaging the environment, running out of power, operating as a monopoly, and creating single points of failure.
Pretty bleak when you lay it all out like that.
Which brings us to the paradigm shift. If building giant, centralized megacenters is becoming unsustainable, the market has to find a workaround. And it turns out the workaround is using hardware that has already been built.
Yes, this is the transition from a top-down corporate model to a bottom-up crowdsourced model. This is DePIN.
Right, and for those following the space, DePIN stands for Decentralized Physical Infrastructure Networks. The underlying concept is pretty wild when you think about it.
Really is.
Instead of Amazon or Google buying 10,000 servers and locking them in a warehouse, 10,000 individuals connect their existing idle hardware to a unified network.
Coordinated by blockchain technology and incentivized through token payouts.
And the sheer scale of this in the 2026 data is staggering. The sector hit a $9 to $10 billion market cap with over 650 live projects.
But the market cap isn't even the most important metric there. What really separates DePIN from previous crypto cycles is the actual revenue.
Okay, how so?
Well, in January 2026 alone, leading DePIN networks generated $150 million in on-chain revenue.
Wow, just in 1 month.
Yeah. And that is not speculative trading volume. That is money coming from enterprise clients, AI researchers, and developers paying for real-world compute and bandwidth. DePIN has actually surpassed crypto oracles in total market cap for this exact reason.
Now, I see that in the notes, but I need to stop you there because the leap from oracles to physical hardware is where I get a bit skeptical.
Sure.
Why should the average person care if this has surpassed oracles? I mean, isn't this just the latest crypto flavor of the month replacing NFTs or, dog-themed meme coins?
It's a completely fair hesitation. If we connect this to the bigger picture, the reason the oracle comparison matters is about how value is actually generated.
Okay.
Oracles, like traditional chain-link data feeds, are incredibly valuable because they feed outside data into a blockchain so smart contracts can function. But oracles just relay the data.
Right, they're the messenger.
Exactly. DePIN networks actually own the physical sensors, the GPUs and the antennas generating that data in the physical world. It shifts the capital expenditure entirely.
Ah, I see.
Instead of a corporation taking on billions in debt to build a network, DePIN creates a virtual network out of idle resources that are already plugged into the wall.
All right, let's look at how this virtual network actually solves the AI compute crunch we started with. The sources break this down into 2 categories. First are DRNs, or digital resource networks.
Yes.
This is for things where the physical location of the hardware doesn't really matter, like raw compute power or data storage. Because if I'm training an AI model, I don't care if the processor is in Tokyo or Toronto. I just need it to be fast and cheap.
And that's exactly what DRNs deliver. Take Fluence Network, for example. They provide GPU cloud computing for AI workloads that is up to 85% cheaper than hyperscalers like AWS or Azure.
85% is a massive margin. But wait, hold on. If I'm a healthcare startup, or I'm developing proprietary AI software, there's no way I'm sending my highly sensitive training data to some gamer's spare PC in Ohio just to save 85%.
Right.
Aren't I risking a catastrophic data breach doing that?
If the data were just sent as raw files, yes, absolutely. But that's not how the mechanism works. These networks utilized advanced cryptography and a process called sharding.
Sharding.
Yeah. Your data is encrypted, broken into thousands of tiny, unrecognizable fragments, and then distributed across the network.
Oh, wow.
So the person in Ohio processing a piece of the workload cannot read the file, they can't reconstruct the data, and they don't even know what broader task their GPU is contributing to. They're literally just crunching mathematical fragments.
Okay, that makes a lot more sense. It's essentially trustless computing, and the demand for that is clearly there. The data shows an AI-native network called IO.net experienced a 445% growth in their GPU supply.
Incredible numbers.
Yeah, they pulled together idle capacity from independent data centers, crypto miners who just had old rigs lying around, and individual hardware owners, generating over $1 million in network earnings.
And you have established players pivoting into this space too. Render is a great example of this.
The visual effects guys, right.
Exactly. They originally built a network for Hollywood visual effects artists to render 3D scenes using decentralized GPUs. But with the AI boom, they realized those same idle GPUs are perfectly suited for machine learning workloads.
That's a smart pivot.
Same with networks like Aether, which are specifically building enterprise-grade GPU clouds to compete directly with Amazon.
So if traditional cloud computing is like building a massive, dedicated, multi-billion-dollar power plant for one single factory, DePIN is like hooking up millions of home solar panels to form a virtual power plant.
Yes.
The energy is already out there, you just need the software to route it efficiently.
Exactly the right framing.
Yeah.
And it applies to storing the data, too. Filecoin has built a decentralized storage network that is, well, almost hard to fathom. They have 3.0 exabytes of committed capacity.
I actually had to look up what an exabyte looks like because the human brain just doesn't process numbers that large.
It's massive.
Yeah, if you took a high-definition movie and hit play, it would take you roughly 1,000,000 years of nonstop watching to consume a single exabyte of data.
Wow.
And they have 3 of them.
It's mind-boggling. And what's crucial is that Filecoin isn't just boasting about empty server space anymore. They hold over 2,000 onboarded real-world datasets.
Okay, real usage.
Right. For AI developers, having permanent, verifiable, and globally distributed datasets that an Amazon executive can't arbitrarily delete or, lock behind an egress fee is absolutely critical for training unbiased models.
Okay, so pooling digital resources globally works beautifully.
Yeah.
But what about the physical infrastructure around us? That brings us to the second category in our sources.
Right.
PRNs, or physical resource networks. This is where the physical location of the hardware is the entire point of the service.
And wireless connectivity is the perfect starting point here. A project called Uplink is transforming how we think about the internet. They've turned over 5 million registered Wi-Fi routers into a global connectivity marketplace.
5 million?
Yeah. Normally, a massive telecom company has to spend hundreds of millions of dollars acquiring land, buying steel, and erecting new cell towers just to expand coverage.
Sure.
Uplink allows networks to just offload their traffic onto routers that are already sitting in coffee shops, office buildings, and living rooms.
And we also have Helium in the notes, maintaining over 371,000 active IoT hotspots, providing decentralized wireless coverage.
Right. Huge network.
But here's where it gets really interesting to me. The mapping sector.
Well, this is fascinating.
There's a network called HiveMapper. You buy a specialized dash cam, stick it on your windshield, and as you drive your normal route, you earn a crypto token called Honey. In just 19 months, this network mapped 257 million kilometers. That is 21% of the entire globe.
It's an insane pace.
But honestly, getting paid in crypto honey to do your miserable commute to the grocery store sounds kind of like a gimmick. How does a decentralized network of gig economy dash cams pose any real threat to Google or Apple, who spend billions deploying highly specialized, LiDAR-equipped mapping cars?
It really comes down to the frequency of the data, which is driven by pure economic efficiency.
Okay.
When Google maps a city, they have to buy a $100,000 vehicle, pay for gas, hire a driver, and cover maintenance and insurance. Because it's so capital intensive, they might only drive down your specific street once every 6 months, or even once a year.
That makes sense.
DePIN crowdsources the commutes that are already happening. A delivery driver, an Uber driver, or just someone commuting to work is driving that specific intersection every single day anyway.
Right, the gas is already being paid for, the driver is already behind the wheel. HiveMapper is just monetizing the byproduct of an activity that is going to happen regardless.
Precisely. And because of that, HiveMapper can provide near real-time updates of street conditions, unexpected construction, or lane closures.
Oh, I see where you're going with this.
If you are a developer building an autonomous vehicle, a map that is 6 months old is completely useless. You need to know what the road looked like an hour ago. That fresh, continuous data is invaluable, and traditional tech giants simply cannot afford to map at that frequency.
It's a fundamental restructuring of infrastructure ownership. The sources also point to the energy and automotive sectors doing the exact same thing.
Yeah.
Like a company called Daylight raised $75 million to coordinate home solar panels and battery walls to balance the energy grid in real time.
Incredible use case.
And Demo has connected over 425,000 vehicles, allowing drivers to finally own and actually monetize their own car's diagnostic data, breaking the monopoly that auto manufacturers have held over that data for decades.
But building a global network of independent actors introduces a massive problem. How do you trust them?
That's the million-dollar question, or I guess the $10 billion question in this case.
Exactly.
If I'm paying for mapped roads or wireless coverage, How does the network know someone isn't just sitting in a basement using software to spoof their GPS location to pretend they are driving, just to mine honey tokens?
This is where the underlying blockchain technology is non-negotiable. To prevent spoofing, networks use consensus mechanisms like proof of physical work or proof of coverage.
How does that work in practice?
Let's take the wireless hotspots as an example. You can't just tell the network, hey, I'm providing a signal in downtown Manhattan. Your hotspot actually has to cryptographically ping other nearby hotspots in the network.
Ah, so it's triangulating. If you're faking your GPS from a basement in a different state, there are no neighboring physical antennas to receive your localized radio ping.
Exactly. The physics of radio waves make it practically impossible to fake. The physical environment acts as the validator. The sources explicitly highlight Chainlink's role in making this work.
Chainlink, right.
Chainlink operates as an orchestration layer, specifically through its runtime environment. Think of it as a highly secure translator.
Okay.
It takes the messy, off-chain physical reality, like a localized radio ping, a sensor reading, or a bandwidth metric, and securely translates that into digital proof on the blockchain. Once the proof is verified, the smart contract automatically executes the token payment to the hardware provider.
And what about the token economy itself? I mean, if everyone is just constantly earning and selling tokens, wouldn't the value just plummet to zero?
That's where tokenomics come into play. Many of these successful networks utilize a buy and burn mechanism to ensure long-term stability.
Buy and burn.
Yeah. When an enterprise client, say an AI research lab, pays for compute power on the network, a portion of that revenue is used to buy the network's own tokens on the open market. Those tokens are then burned, meaning they are permanently sent to a dead address and destroyed.
So it's like a corporate stock buyback. By constantly reducing the total supply of tokens, you create a deflationary environment that supports the value of the remaining tokens held by the hardware operators.
Right. And there are penalties too. It's called slashing.
Yeah.
When you join the network, you usually have to put up a security deposit. If you act maliciously, or if your hard drive goes offline and drops a client's data, the network automatically slashes or confiscates your deposit.
Ouch.
It forces everyone to have real financial skin in the game.
It's an elegant system on paper, but the sources are very clear that this isn't some flawless utopia. There are massive hurdles.
Oh, absolutely.
The most obvious one is the cold start problem. If I build a decentralized Uber, how do I convince drivers to wait around before there are riders? And how do I convince riders to download the app if there are no cars available?
It's a brutal chicken and egg scenario.
Plus, there's the regulatory nightmare. If you are suddenly broadcasting a commercial wireless signal from your balcony or monetizing dashboard footage of public streets, you are colliding with telecom regulations and data privacy laws across dozens of different international jurisdictions.
Those are significant friction points. But the most existential threat to DePIN, historically, has been the volatility of the crypto market itself.
Which makes total sense. Think about it from the user's perspective. Imagine you've invested $5,000 in a high-end GPU rig specifically to provide compute for a DRN. You are budgeting your electricity costs and your potential profits.
Right.
How absolutely devastating would it be if your compensation crashed 50% overnight simply because Bitcoin had a bad week on the macroeconomic stage?
It would completely break the utility. You would see a mass exodus of hardware providers unplugging their machines because the unit economics no longer makes sense.
Yeah.
You cannot run a foundational physical utility on a highly speculative, volatile currency.
So how are the top networks surviving that volatility in 2026?
By maturing their payment models. The industry is aggressively shifting towards stablecoins. Rather than paying hardware operators in native, fluctuating crypto tokens, clients pay for the service in cryptocurrencies that are cryptographically pegged one-to-one with the US dollar.
Ah, okay.
This completely insulates the hardware providers from the chaotic swings of the broader crypto market. If they provide a dollar's worth of computing power, they get exactly a dollar's worth of stablecoins. It brings predictability to the ecosystem, which is the only way you attract serious enterprise-level infrastructure providers.
So we've covered a lot of ground today. Let's pull all these threads together. We started by looking at a centralized cloud system that is buckling under the weight of the AI boom, devouring immense amounts of power, trapping innovation behind massive egress fees, and creating fragile single points of failure. And we've seen how that bottleneck has paved the way for a $10 billion decentralized revolution. DePIN is actively turning every day. Idle devices, dash cams, Wi-Fi routers, spare graphics cards, and home solar panels into a global, crowdsourced grid that is fundamentally challenging the biggest tech monopolies on Earth.
It's a profound economic shift. We are moving capital expenditure away from monolithic corporations and distributing it to everyday individuals, effectively democratizing the physical layer of the internet.
So what does this all mean for you? It means the next time you look around your home or your office, you might want to look a little closer at the devices around you. That gaming computer asleep on your desk or the dash cam sitting in your car are no longer just consumer electronics. They are the potential nodes that will power the next iteration of the digital economy.
And to leave you with one final, slightly mind-bending concept from our research, we've spent this entire deep dive talking about humans buying hardware and renting it out to networks. But analysts at Outlier Ventures are currently tracking the rise of what they call agent-to-machine economies.
Agent-to-machine economies.
Yeah. Consider this scenario. In the near future, what happens when autonomous AI agents become the primary customers of DePIN? You might soon see a situation where an AI agent independently recognizes it needs to expand its own processing power to solve a complex problem.
Okay.
That AI goes out, sources decentralized GPU power on its own, and pays the decentralized network directly using stablecoins. It would be an entire self-sustaining economy run by machines, buying resources from machines, completely cutting humans out of the economic loop. Something to mull over until next time.